One of his research works is incorporated SPM of open source data mining tool. He has received 8 awards so far, which includes award for Distinguished Technical Advisor from Danvi Infotech Private Limited during 2019 and received a Favorite Teacher Award from the management of Karpagam Institution during 2017 and acquired first position in NLP Challenge as part of FIRE 2018 conference. He also successfully completed more than 601 online certification courses in Coursera and completed 41 specialization course and 4 professional certifications. He has published 3 patents so far and received funds for seminar and workshops from various funding organizations. He has delivered about 107 guest lectures so far. He also published his works in various national and international journals. He is a lifetime member of Indian Society for Technical Education. He is a professional member of LMCSI, LMISTE, MIEEE, and also a lifetime member of IAENG. It is a great privilege to have such a wonderful, energetic, and eminent personality with us today. We feel honored by your presence, sir. On behalf of VCET and Department of Computer Science and Engineering, we once again welcome you, sir. Now let's invite our resource person of the session, Dr. S. Kanimuthu, sir, to move the session forward.
Thank you, ma'am. First of all, I thank the management of VCET, HOD CSE, and Kairveli Madam for providing this opportunity to present a session on challenges and potential benefits of the integration of blockchain and IoT in STTP on IoT with blockchain applications and challenges. In today's agenda is to discuss about IoT and its architecture, and I will come across challenges to secure IoT deployments, issues in centralized systems, and how to decentralizing IoT. Then I will give fundamentals of blockchain technologies with the demonstration, and I will tell about benefits and challenges of integrating the blockchain and IoT. I think we came across the fundamentals of IoTs and blockchains in previous days. I wish to review some of the concepts, and I will get into the benefits and challenges of blockchain and IoT. What is IoT? Actually, IoT discusses the network of physical object, also called as things that are embedded with sensors, also called as hardware, software, and other technologies for the purpose of connecting and exchanging the data with other equipments and systems over the internet. Okay. Actually, IoT has extended the internet connectivity to reach not just computers and humans, but most of our environmental things. So we can connect with the environment with the help of computing devices by using the IoT technology. Actually, the IoT has a potential to connect billions of objects simultaneously, which has the impact of improving the information sharing that means results in improving our life. After receiving the data from the different equipments, we can do data analysis and make effective decisions. That is the purpose of IoT. IoT as a concept is exciting. It has exciting features, but one of the major challenging aspects of IoT is having a secure ecosystems which covers all building blocks of the IoT architecture. The major concern in IoT is security. That is why we are going for blockchain. Okay, we are integrating IoT with blockchain. So understanding the different aspects of IoT and identifying the areas of vulnerability in each block and exploring the technologies necessary to counter each of these weaknesses are essential in dealing with the security aspects of IoT. So before getting into the blockchain with IoT, so I wish to tell some concepts pertaining to IoT architecture. So there are four main key players in IoT architecture. First one is things, followed by network infrastructure. We make use of gateways and cloud infrastructure. I explain one by one. As I told, there are four building blocks. First, I start with the things. Actually, things are defined uniquely identifiable nodes, primarily sensors that communicate without human interventions or human interaction using different connectivity methods. There are different kind of methods we deal with. Each have unique features, has its own features. By using the internet, we connect these things. And we have another component, gateways. These act as intermediaries between the things and the cloud to provide necessary connectivity, security, and manageability. So gateway is acting as a broker. Next, we have network infrastructure. This consists of routers, aggregators, gateways, and repeaters, other devices that controls and secure data flow. That is the purpose of network infrastructure. Finally, we have cloud infrastructure. Cloud infrastructure consists large pools of virtualized servers and storage that are networked together with computing and analytical capabilities. So, cloud infrastructure contains several servers which provides several services like software as a service, infrastructure as a service, and platform as a service. Basically, we use cloud infrastructure in IoT uh, for making use of storages. Existing security technologies uh, plays a major role in mitigating IoT risk, but they are not enough. The goal is to get data securely to the right place at the right time and right format. So, conventional security method is not applicable for the IoT systems. Still, we have an issue. It is easier said than done for many reasons, and here is a list of some of the challenges. Okay, the challenges that we face while securing the IoT deployments. Many IoT systems are poorly designed and implemented, using a different variety of protocols and technologies that produces complex and sometimes conflicting configurations. And we have a limited guidance for the lifecycle maintenance and management of IoT devices. So that is a major reason uh, to face some challenges in IoT security. IoT privacy concerns are complex and not always readily evident. So there is a lack of standards and compliances for authentication and authorization of IoT edge devices. Security standards for platform configurations involving virtualized IoT platforms supporting multi-tenancy is immature. Okay, so standards compliances are immature. The uses for IoT technology are expanding and changing. Okay, people are major. I mean, in wider areas they are using IoT. Okay, but the security is very less. Okay, securing the data and devices is very less. In addition to this list, new security technologies will be required to protect IoT devices uh, and platforms from both information attacks and physical tampering to encrypt their communications and to address new challenges such as impersonating things. Sometimes you may face a denial of sleep attacks. Okay, that drain batteries. Okay, batteries that is usually in the devices, which leads to a denial of service attacks. So there are different kind of attacks that you face in IoT system uh, that has to be avoided, okay, with the help of new security technologies. But IoT security will be complicated by the fact that many things use simple processors. Okay, the problem is we use simple processor and operating system that may not support sophisticated security approaches. That is the main thing we face. The configuration is very low for the IoT devices. The prime example of the urgent need for such a new security technologies and standards is the recent massive distributed denial of service attacks, DDoS attacks, that crippled the servers of popular services like Twitter, Netflix, New York Times, and PayPal across the US October 21st, 2016. Recently, 2020, last month of 2020, PayPal again faced this issue. Okay, which is with respect to security. They have stolen the hackers have stolen the PayPal data, which consists credit card information, that is transaction details and all. Okay, that is a major security loophole. It was during 2016. There was an immense assault that involved millions of internet addresses and malicious software. One source of the traffic for the attacks was devices infected by the Mirais malware. Okay, this is a major reason we had an issue. The attack comes amidst heightened the security fears. Okay, it creates a security fears and raising a number of internet security breaches after on. So all indications suggest that countless IoT devices that power everyday technology like closed circuit cameras and smart home devices, which are hijacked by the malware and used against the server. Okay, that is why we are willing to secure the IoT devices and deployments. But while applying the security model, we need to deal with the model that is a system. Okay. Uh, Currently, we are most of the system using the centralized IoT model. Okay. So current IoT ecosystems rely on the centralized brokered communication models, otherwise known as the client server paradigm. So here all devices are identified and authenticated and connected through the cloud servers that support huge processing and storage capabilities, which has single point of failure. Okay. Connection between the devices have to exclusively go through the internet, even if they happen to be a few feet apart. Okay, every time, for example, the two devices are in nearest position, but uh, in centralized model, by using the internet only, we need to communicate with others. Okay, there is a problem. While this model has generic computing devices for decades, and it will continue to support small scale IoT networks. As we see them today, it will not be able to respond to the growing needs of the huge IoT ecosystem of tomorrow. Okay, so in future we will deal with huge number of devices which is connected with the internet. Okay, if you use centralized system in IoT system means we will face many issues in terms of performance and security. So existing IoT solutions are expensive because of high infrastructure and maintenance cost associated with the centralized cloud, large server farms and network equipment. Okay, so I mean network equipment cost and the centralized cloud cost is very high when compared to the distributed decentralized system. The large amount of communications that have to be handled when there are tens of billions of IoT devices will increase those costs substantially. Even if the unprecedented economic and the engineering challenges are overcome, cloud servers will remain a bottleneck and point of failure that disrupt the entire network. Okay, if you use a centralized system, means we will have a performance issue and security issue. So we use decentralizing, that is IoT network, which is also called a distributed network. See, a decentralized approach to IoT networking would solve many of these issues discussed before. So, adopting a standardized, that is, decentralized network makes use of peer-to-peer communication model to process the hundreds of billions of transactions between devices will drastically reduce the cost associated with the installing the device and
in
maintaining
academic
the
and
large
research
centralized data
activities.
centers
It is a
and
great
will
privilege to
distribute the
have
computers
such a
and
magnificent
storage needs
personality with us
across the
today.
billions of
We
devices
feel
that
honored.
form IoT networks. So the installation cost, maintenance cost, and the computation cost, storage needs that will be drastically reduced if we use decentralizing IoT network. This will prevent the failure in any single node in a network from bringing the entire network to a halting for collapse. If you use centralized system, we will face a single point of failure. When server fails, means cloud server fails, means the entire system will get failed. If you use distributed network, means failure of one system will not affect other system or entire systems. That is the use of decentralizing IoT networks. Okay, this is the example for peer-to-peer network communications. We have separate connections between one system to another system with the help of internet. Okay. So, however, establishing a peer-to-peer communication will present its own set of challenges. See, among the issues of security, and as we all know, yet IoT security is much more than just protecting the sensitive data. Okay, the proposed solution will have to maintain privacy and security in huge IoT networks and offer some form of validation and consensus for transaction to prevent spoofing and theft attack. So we need to keep track of validation and consensus for transactions to prevent from the attack. To perform the functions of traditional IoT solutions without a centralized model, any decentralized approach, or it is also called as a distributed approach, must support three foundation or fundamental functionalities. One is peer-to-peer messaging. It means that it is a process of sending the messages directly between the two people. That is called peer-to-peer messaging. And the other functionality is distributed file sharing. So in distributed file sharing, we use distributed file system that is distributed on multiple file servers and multiple locations. Okay. And the third functionality is autonomous uh, device coordination, which aims to collect and process data in real time from the environment for a long duration. Okay, so we have a coordinator for handling these things. Okay, collecting the data and processing the same. So we rely on, okay, for improving the security, enhancing the security. We rely on blockchain approach. So the blockchain, it is also called as distributed ledger technology, has emerged as an object of intense interest in the technology industry and beyond. Blockchain technology actually offers a way of recording the transaction or any digital interaction or communication in a way that it is designed to be secure, transparent, and highly resistant to outages, and it is auditable and efficient. As such, it carries the possibility of disrupting industries, that is, which makes use of contemporary technologies and enabling a new business models. So blockchain uses new kind of data structures, okay, linked data structures to keep the data more secure. So the technology is very young and changing very rapidly. Nonetheless, to avoid disruptive surprises or missed opportunities, strategists, planners, and decision makers across the industries and business functions should pay heed now and begin to investigate the application of the technology. It's not only meant for business transaction. We can apply blockchain technology in different areas, okay, like IoT, machine learning, and other applications in domains like medicine, agriculture, etc. So, blockchain is a database that maintains a continuously growing set of data records. It is basically distributed in nature, meaning that there is no master node. There is master computing holding the entire chain. Okay, so here we have different kind of system which interact with each other. Okay, without any mediator. Rather, the participating nodes have a copy of the chain. It is also ever-growing. Data records are only added to the chain. Okay, so there are two basic elements of blockchain. One is transaction, another one is blocks. Transactions are the actions created by the participants in the system. Uh, Blocks record these transactions and make sure that they are in the correct sequence, and have not been tampered or altered with. Okay, so the basic drawback of current transaction system is we have a centralized system. For communicating with for making the transaction with the other person, we need an intermediator. Okay, there is a, we need bank record, audit records. Okay, so if it leads to a single point of failure if the data maintained in the bank is erased or destroyed, means the entire the system will be collapsed. Okay, so that is why we are using distributed technology. Okay, the blockchain technology makes use of distributed technology by making the transactions and computing for computation purpose. Actually, the Bitcoin, that is blockchain technology, is first coined by the Santoshi Nakamoto during 2008. He published a research article, okay, titled "Bitcoin: A Peer-to-Peer Electronic Cash System," which acts as a foundation for blockchain technology. Okay, so he proposed a digital currency, okay, method for the digital transaction, okay, by using the peer-to-peer network. So here I'm in a position to compare blockchain with IoT. Actually, blockchain is a decentralized system network, and IoT is a centralized network. Okay, blockchain consumes more resources, and in IoT, the resource is restricted actually. The blockchain mining, the block mining is time with one of the tasks in blockchain. Okay, uh, in business transaction we give a mining task, block mining, time consuming task. Okay, which needs more computational power. Okay, but in IoT it demands low latency. The in blockchain the scale poorly with large network. Okay, but IoT considered to contains large number of devices. Okay, scalability is not a case in IoT. Blockchain consumes a high bandwidth, but in IoT have limited bandwidth and resources. Blockchain has better security, but in IoT, security is one of the big challenges that you face. These are the comparison between blockchain and IoT. Here, in blockchain technology, we deal with the digital currency, that is virtual currency. One of the example for cryptocurrency is there is secure money is Bitcoin. It replaces cash with numbers. It has several advantages, like it is very fast. It is internationally widely accepted. Some of the countries are banned the digital currency. Mm, Easy, it is. We can maintain the accounting easy. It weighs nothing. Okay, since it is a digital currency, it's something like a file only. It is very cheap. The existing technique in a business transaction or banking transaction, we need a centralized banking system which is not robust. Actually, Santosh is determined to find the centralized part of the banks. That is called he maintained ledger. What if I go turn a bank inside out instead of a central party controlling the ledger? Actually, bank in centralized system, bank is maintaining the ledger. What if user were recruited to maintain the constantly updated copy? Okay, so we have in a network, in decentral network, each node, each peer have own copy of ledger. Okay, so that intermediary is not needed. Okay, for the blockchain technology. The strength of the digital was perfect copies. So copy the ledger everywhere instantly. Okay, each node has its own copy. Okay, any ledger with even one common not agreeing with the masses would be discarded. Okay, if any one of the system is violate the any one of the ledger violates the other system means it is just discarded. It may be a fraudulent transactions, okay, which may be a powerless system. Actually, the blockchain technology replaces the cash with the ledger. Actually, okay, something like a business ledger. We are maintaining the digital ledger. Okay, each peer maintains the ledger. Okay, digital ledger. It's also called a distributed ledger. So here I'm in a position to compare the centralized system with the decentralized system. Okay. Uh, Distributed ledger can be public. Okay, 1 minute. The distributed ledger can be public or private and vary in their structure and size. Okay. So in centralized system, we have one main server and every system can connected with the server. Failure of a server will spoil the entire system. But in this decentralized system, all systems acting as a coordinator. Okay, we are not having master slave communications and all. So the ledger are maintained in all the nodes. Okay, but we require computer processing power to confirm transaction whether transactions are successful, made successful, or not anonymous. Okay, actually, the decentralized ledger is not new topic. Okay, which has a history. Um, the base for blockchain technology is cryptography. So, which has a history from 1980s to 2001. Okay. So, during 1980s, public key crypto system evolved, algorithm evolved. Later on, you have proof of work system for spam and hashing technique has evolved. During 1998 itself, a Bitcoin, that is cryptocurrency, was invented. It was invented by Nick. And during 1998, there is a one digital currency called B money was invented by Bay. And during 1999, peer-to-peer networks has evolved. Okay, and we have fault tolerant system, which Anton fault tolerant system as invented during 2001. SAR 256 finalized. This technique is this is one of the hashing techniques which is mainly used in blockchain technology to maintain the integrity of the system or distributed ledger. During 2008, Santoshi coined two major technologies. One is proof of work to solve a double spending problem, and another technique is elliptic curve cryptography, okay, to solve unique access to the ledger. Okay, so in terms of authentication, author security, confidentiality, he devised two technology. So here we use a decentralization method to get rid of the third party. So one of the example for blockchain technology is Bitcoin, which stores all transactions into a public database called blockchain. So I will tell how blockchain works. Okay, in terms of business transaction, digital transaction. So if someone wants to initiate a transaction means the requested transaction browser to the peer-to-peer network. It consists of computers known as nodes. The network of nodes validates the transactions and the user status using known algorithms. Okay, by using consensus mechanism, it will just validate the transaction. Okay, the consensus mechanism is something like a computer code which validates the transaction. Then after a transaction verified, which involves cryptocurrency, contracts, records, and other information. Then once verified, the transaction combined with the other blocks, okay, which is a chain of records. So to create a new block of data for the ledger, we need to validate and verify it. Okay. Finally, it will be indicated to the user that the transaction is complete. Here, here we deal with the cryptocurrency, which is a digital file which has no intrinsic value, in that it is not redeemable for another commodity such as a gold. Okay, it is not redeemable actually, which has no physical form. Okay, the power of cryptocurrency, which has no digital physical form, and it exists only in the network. And the third thing is its supply is not determined by the central bank. Okay, it is anonymous. The transactions are anonymous. Okay, which is not controlled by any centralized authority. Okay, these are the simple example for business transaction made in blockchain. So this is the animation. Okay, this is retrieved from the sources, internet sources. Every time the blocks is ordered, if you use to initiate the transactions, it's a chain of records, something like a linked list in a transaction, linked list in a data structure concept. Just a minute. I will take a water. Just a minute. I shall continue this session. As I already told, blockchain is something like a linked list, okay, which was discussed in. You may come across data structure. This blockchain data structure, also called as chain of records, contains the data members like person information, no ends, which is something like a random number, and the address of the previous block. Then we have another field timestamp. Okay, and we have other information that is transaction ID list. This is a simplified block structure. Okay, I will show demo which is pertaining to blockchain. And you will get to know about this, which is freely available. This tool, web application is freely available. So we come across this demonstration. Anyone told about this demonstration? Anyone reply, please? I think this demonstration is not mentioned by anyone. I think so. As I already told, block contains several fields. I just mentioned some of the fields. This is the demonstration for block. Okay, we have some of the important fields. One is block ID, that is a reference number, and noise, which is something like a random number, which is mainly used for mining, blockchain mining. And we have some data, internal data, which is mentioned by the author, this Anderson. For every data that you mentioned here, maybe if you make a business transaction means it contains some information that is data transaction, money transaction information. If you consider IoT technology means this data block contains the information which is sent by the sensors. Okay, consider that. Yes, unique ID that is hash value, this hash value is generated by STAR-256 algorithm. Okay. Please understand that this is considered to be a fingerprint, unique fingerprint, digital fingerprint for the data. Now I wish to change some data. Okay, I wish to introduce BCET. Automatically, okay, this block marked as a red since you have changed the data. Okay, and you may notice that this digital fingerprint has changed. Okay, so for every data we have unique fingerprint. Okay, there is a power of blockchain. Okay, the blockchain involves set of blocks. I hope you understood. Please reply. Can you reply, please? Okay. So if I change a single text, even single character, the hash value is changed. You may notice that. Okay, you have no clue how it is changed. Okay, okay, that's it. Already it has some text. Okay, which has some leading zeros. Okay, which is done by miner actually. So I just change a single text. Automatically, the hash value is changed. Digital fingerprint, which is marked as invalid. Okay. For example, I made the change VCET. Just I changed. If I wish to validate this transaction, means I need to use the miner, Bitcoin miner. I just use miner. Now, the transaction is validated and is found to be correct, but the nuance value is changed. So, initially it has some value. Okay, some value. Nuance value is 7208. I have changed it to BC. It is marked as invalid. Now, what you do is by using mining concept, manually you can mine it to come up with a original digital fingerprint. I just change one, no change. I just make two, no change. I just mention no value three, no change. It's not validated. Four, no change, no change. Five, no change. Six. So you're trying all the possibilities uh, to get digital fingerprint saved. Okay. So if you do manually means you will uh, end up with no solution. Okay. So we are using mining task. If you have more computing power means this miner will give result quickly. So now initially the nonce value is something it may be available in terms of thousand. Now new nonce value is 1,19,120. So the digital fingerprint is generated and validated based on the nonce value, and this is done by the miner. This is the example for block. Now I'm moving to blockchain demo. So here blockchain contains chain of records. Here I have a set of records: blockchain 1, blockchain 2, blockchain 3, blockchain 4, and blockchain 5. A total of 5 records I have. Each block contains the blockchain ID, nodes, and data section. This is a first block which has zeros, all zero value as a hash value. There is previous record. There's something like a linked list I already told. And we have a digital fingerprint for the hash value. And the second block contains the address of the previous block. It is hash value of previous block. See here, we have hash value here. Same hash value is available in the second block, which is mentioned in the previous section. Similarly, block 3 has the previous record, and block 4 has block 3 record, and block 5 also have previous value. Okay. And each block contains a unique digital fingerprint. Okay. So by using it has 4 leading zeros in every digital fingerprint. Okay. It is done by the algorithm, consensus algorithm. Now what I do is I just make a change. Simple change. Since this block only I have made a change. So this is marked as red invalid. If you wish to do if you wish to validate the transaction, just I need to use my tab. Click my tab. When I change single value, digital fingerprint was changed, but there is no change for previous address of previous record. There is hash value of previous record. Okay, since the block by only we made a change. Other block in other block we don't change any value. So 4 blocks are valid and fifth block is invalid. Okay, I hope you understood. Now I made a change in the fourth block. What happens? Fourth block and fifth block also marked as invalid. Okay, and just to notice the value, block value, this has value change. Has value for this one is changed because I made a change in block. So 4 blocks out of 5 blocks, I just made an intermediate block. So after fourth block, the entire transfer will be marked as invalid. In similar way, the transaction. Okay, made change. may happen. So I just made a change in third block. Okay, if I wish to validate the transaction. Okay, by using main task, I just validate transaction. Just here main, but here is not main. Here it is marked as invalid since the previous address is different. This should be validated. No? This address is different. Here also I need to validate. Okay, it says sometimes because it needs computing power. Any one of the data block is changed means you need to uh, and all the data which is after the block are marked as invalid, then we need to mine it to validate the transaction. This is the concept behind blockchain. Next, how do you apply decentralization, that is distributed blockchain, by using peer-to-peer network? In this demo, I have three peers, peer A, peer B, peer C. Okay, please understand that each peer have five blocks. Okay, block one, block two, block three, block four, block five. And we have three pairs. Each pair maintains the ledger, these blocks. Okay, see here. We also have same thing. Okay. So each pair maintains its own copy. Okay. If any one of the system invalid means in the end, we can recover the data ledger from the other pairs. Okay. So to make all the ledger same means you need to validate it. For example, I made change here. The, okay. Okay. So if someone consider someone has tampered your system, that is altered your system. Okay. And this is marked as red and all the trans marked. Well, how do you evaluate your your system is tampered by someone? By comparing the others ledger. Okay, peer B, peer C ledger, we can compare that. Fully compare, just to see the hash value. Hash value is changed, Based on the hash value, you can compare the records. Let's say distributed ledger. Okay, so that you can identify whether cracking is happened in the distributed ledger. Okay, so we are just replicating the data. Okay, the advantage of decentralization is we are just replicating the data. Okay, so we can, which leads to a multiple, which avoids the single point of failure. The failure of one system will not affect the other system. And we can validate the system by using the hash values. Okay, this is called blockchain, distributed blockchain. Okay, I hope you understood this concept. Next example is token. Okay, actually, the business transaction, the money transaction involves distributed ledger like this. Okay, here we have block, known value, and in transaction, this is considered to be a distributed ledger, which also collects data, which contains information like how much amount you have transferred from Daisy to Bingley. In the same way, we have transaction details of others. Okay, in block PRB also we have same transaction details for block A, that is block one. PRC also maintains the same thing. Okay. Now I wish to steal the data, just change the data, just for lecture. I just change the data. What happens? It's marked as invalid. How do you evaluate it? Just compare with other transactions. Okay, if you wish to, you are not a hacker. Okay, you just wanted to edit the data means you have to use higher computing power, that is consensus mechanism, like proof of stack, proof of work, to validate the transaction. Here, just to validate the transaction by using my data. Because I made a change in the transaction, I just mined. Okay. Here I have to make a change. This needs a higher processing power. So by using these concepts only, the Bitcoin transactions are made. Okay. So if you wish to get to know about the value of Bitcoin now, one Bitcoin is equivalent to 29 lakhs now. Okay. So it is growing exponentially. So the Bitcoin value during 2009 is very low because it is introduced in 2009. You know, later on, $1,000 came, and now we have a huge amount. So in US, Mercedes dollars is 40,261. Okay, so with a lot of business transactions are happening through cryptocurrency. Okay, so for example, Bitcoin transactions made by using distributed ledger only, and we have one issue in this token this system. What is the system mean? For example, uh, we have a distributed ledger. Okay, for example, here I have information like reply. Reply is transferring the amount to Lambert. Okay, $97 it is transferred. So, but it does not ensure whether $97 is available with the reply or not. Okay, it does not ensure, no. That has to be resolved with the help of Coinbase. Okay. Yeah, I introduce another block which contains the information about the uh, how much amount the person source is having. It is called Anders. Anders he is the source. He is having the money, $100, used to make a transaction to some other person. Okay, so this is a Coinbase. With the help of Coinbase, we can understand, we can analyze how much amount I have so that I can transfer the amount to this amount. Okay. So this also contains other information like previous has a previous block and has a unique value. What is the unique fingerprint? Uh, Fingerprint for the block. Okay. Here I have $100 and does have $100. Okay, in his account. Now he wishes to make a transaction to Sophia. That is possible because he is already having the $100. No, so the 100 is okay transfer, and he have that is Anders willing to transfer $20 to local. This happens. So the data it just contains the transfer information what is this? Okay. So the balance details are not maintained here. Okay. Remaining balance and all will not be maintained here. Whether it just ensures whether it is possible to transfer the amount to the recipient. Okay. So that information may be maintained and validated against the current balance. Okay. So whatever changes made here also reflected in the other phase. Since we are maintaining the distributed ledger. So this is the simple demonstrations which is pertaining to blockchain. Okay. I also saw the coding example. Okay. After 15 minutes, I hope you understood about blockchain, block and nodes and distributed ledgers and all. As I already told, the four key concepts of blockchain is distributed shared ledger. Each phase maintains its own ledger, and we use a cryptography algorithm, okay, for ensuring the security, enhanced security, and we have consensus mechanism, okay, to validate the transaction by using proof of work concept, proof of stack concept, and proof of storage concept. And we have a smart contract, which also called a smart agreement, uh, which will be done between the source and recipients. And this smart contract is something like a program or code. Okay, so we use it to perform the transaction. As I already told about this blockchain is a distributed ledger technology, which has several benefits. Okay, it just reduces the cost of overall transaction and IT infrastructure. Okay, we are playing with the software only, not much in hardware, but my other task that is maintaining the data and validating that or validating the transaction. We need a higher processing power, and it is irrevocable and tamper-resistant transaction. It reduces systematic risk. Okay, and also it make it validate the transaction and make smart contract, and it is able to store and defend oneself of any tangible and intangible asset. It has increased accuracy of trade data and reduces settlement risk. Uh, the clearing and settlement is very easy. It has improved security and efficiency, and it enables the effective monitoring and auditing by participants, supervisors, and regulators without any intermediators. Okay. So it has a long history from 2009 to 2020. In 2009, the foundation day, Santosh coined the blockchain technology that I was cryptocurrency. He introduced the digital currency. Okay, here blockchain is a backbone of Bitcoin. Okay, he just invented the Bitcoin. And 2012 to 14, the rise of Bitcoin exchanges happened. Mixed response to Bitcoin as it struggles with money laundering and criminal activity because of lack of security, but it also gains acceptance across some online retail stores among others. And there are many startups came into exist during 2012 to 14. Okay, and during 2012 to 14, when the price of Bitcoin raised to $1,000. Okay, Bitcoin gains an attention of financial services firms. Okay, which don't need intermediaries. During 2014 to 15, blockchain technology began serious attentions and investment happened in an organization with the help of blockchain technologies. Okay, there are many capitals and banking and financial services industries makes use of blockchain. Okay, and during 2016-17, the next 2 years are critical for the blockchain technology to demonstrate sustainable value and maintainable value. Uh, Actually, all startups during 2016-17, all startups backed by venture capital funding and consultant need to show the results to justify large sum of funding. The scalability during this year, the scalability and the throughput issues was solved for the blockchain technology to cross the session to mainstream adoption. During 2018 to 20, uh, regulatory bodies likely to play a key role in the facilitating adoption of blockchain technology. IT service providers likely to accelerate the investments to build capabilities around the rise of IPOs and unicorns in the blockchain startup ecosystem. Okay. So in 2020 or later on, there is nowadays uh, bank infrastructure's cost for cross-border payments, security trading, and regulatory compliance reduced to $15.20 billion a year from 2022, according to the recent report by Spanish bank Santander. Blockchain will gain adoption within and beyond BPSC, okay, banking and finance services. It may be used for other technologies like IoT, medicine, and other areas. Okay. Uh, Blockchain is referenced in two major shifts expected to occur in the nearest future. Okay, which will create impact in World Economic Forum. Okay, and it may be used in electoral voting system and other applications. So there are three revolutions of blockchain technologies. Okay, in blockchain version 1.0, Bitcoin, that is digital currency, exist, and we have developed a programmable money. In blockchain 2.0, there is another digital currency, the Ethereum came to exist, and we had a invention in smart contract. Okay, by using programmable code. And in blockchain 3.0, we used blockchain technology for non-financial purposes, and it has several applications. And it uses underlying technologies like TCP/IP, STTP, cloud computations, big data technologies, IoT, and financial technology evolutions. Okay, so it means these are already existing technologies. Okay, to make effective transactions and computations. So I need to compare with Bitcoin system with current banking system. Here, the main another advantage is decentralization system. So the blockchain system follows a decentralizing approach when compared to the banks, because the bank we have intermediaries. Here, everyone in decentralized system, everyone is considered to be involved with the system, which holds some power. Okay, if any changes happen, means you need to validate with the other ledgers. Okay, here we have public ledger, which holds the details of all transactions which happen on the blockchain. It's open and completely accessible to everyone who is associated with the system. Even though the complete ledger is publicly accessible, the details of the people involved in the transaction remains anonymous only. Okay, but data is accessible. Ledger is publicly accessible, but who is assessed that information? There is a what are the users they are using the money or transaction made. That information is anonymous only. Here, verification of every individual transaction happen. Every single transaction is verified by the cross-checking the ledger in a peer-to-peer communication network, and the validation signal of the transaction is sent after a few minutes. Through the use of a several complex encryption hashing algorithm, the issue of double spending is avoided. So it has low or no transaction fees. The transaction fee is very less when compared to the banking centralized banking system. So the transaction fees are, however, relatively quiet when compared to the banks and other financial organizations. The key business benefits, time savings, the streamlining and automating process with the blockchain transactions can be completed faster when compared to and efficiently when compared to the centralized banking system. And then cost savings is another key business benefit. You don't need as many third parties or middlemen to make guarantees, because it does not matter if you can trust your trading partner. Then we have tighter security. New transactions are linked to previous transactions by cryptography, which makes blockchain networks resilient and secure. And other key business benefits enhance the privacy. The in transactions, business transactions must be agreed upon before they are recorded. After transactions are approved, it is encrypted and linked to the previous transaction, and it has to improve auditability. Okay, so auditability means verifying the chain of blocks, which involves auditing digital assets, also called as cryptocurrencies. Then it has increased operational efficiency. Like actually, blockchain will simplify and accelerate security issuance and settlement by requiring the participation of few parties, ultimately reducing the transaction fees. In special case, we have, for example, if you need more priority in validating the transaction means, which leads more computing. That is transaction fees. Okay, in special case, we need a transaction. We need to pay transaction fees in a blockchain technology. Okay, how do you build a trust with blockchain technology? Since the blockchain technology is distributed, since it is a decentralized system and sustainable, okay, the blockchain technology is more secure when compared to the centralized one. It is private, which in fact distributed is accessible to any system. The transactions are anonymous, and it is persistent one. Everything in the transaction is transparent and auditable. Okay, by using consensus mechanism. and it is streamlined and flexible one. Okay, so this is the advantage of using blockchain. So why it is called blockchain? Because it contains set of several blocks and we have linked structure. Okay, in linked list we have a set of nodes. Each node contains data point and address of next node. Likewise, we have every node contains a hash value of previous block, etc. Here, what are the advantage of blockchain? Big advantage of blockchain is that it is public. Okay, everyone participating can see the blocks and transfers and store them. This does not mean everyone can see the actual content of the. However, the data is protected by a private key. The blockchain is decentralized, so there is no single authority can approve the transaction or set up specific rules to have transaction accepted. That means there is a huge amount of trust involved since all the participants in the network have to reach a consensus to accept the transaction. Okay, if any changes happen in the decentralized network. Most importantly, it is secure. The database can only be extended and the previous records cannot be changed. Okay. As I already told, there is a very high cost if someone wants to alter the previous record. Okay. So the hacker will not prefer if he is to spend more amount of money. So when someone wants to add a transaction to the chain, all the participants in the network, that is the peer-to-peer network, will validate it. They do this by applying the algorithm to the transaction to verify and validate it. What exactly is understood by validity is defined by the blockchain system and can differ between systems to system. Okay, it is not fixed, it is varied. System to system is varied. Then it is up to a majority of the participants to agree that the transaction is valid. Then a set of approved transactions then bundled in a block, which gets sent to all the nodes in the network. They in turn validate new block. Each successive block contains a hash, which has digital fingerprint, that is unique fingerprint, which is a unique fingerprint of the previous block. Here, I used to tell core part of our session. There is blockchain and security. Blockchain technology is a missing link to the settled privacy and the reliability concerns in the Internet of Things. Okay, it is used to uh, enhance the privacy and security in IoT. Actually, blockchain technology perhaps is a silver bullet needed by the IoT industry. It is a core part of IoT industry. It can be used in tracking the billions of connected devices through network, the internet network, enabling the processing of transactions and the coordinating between these devices. This basically allows for significant savings for IoT industry manufacturers. This decentralized approach would eliminate the single point of failure. Particularly, if we apply blockchain technology for IoT, means we will eliminate single point of failure, creating a more resilient ecosystem for devices to run on. The cryptographic algorithm used by blockchain would make consumer data more private. There is a power of blockchain in IoT. So the ledger which is maintained in the blockchain is tamper-proof and cannot be manipulated by malicious actors because it does not exist in any single location. And the main in the middle attacks cannot be staged because there is no single thread of communication that can be intercepted. If a man in the middle attack has happened in any network, then the attacker will need to change the ledger for other networks also. It's very highly complicated task. So blockchain makes trustless peer-to-peer messaging possible. It has already proven its worth in the world of financial services through cryptocurrencies such as Bitcoin, Ethereum, providing the guaranteed peer-to-peer payment service without need for third-party brokers. See, it is a proven technology in financial industries, so we can use blockchain for IoT. Since it is a decentralized, autonomous, and trustless capabilities of blockchain, makes it an ideal component to become a foundational elements of IoT solutions. It is no surprise that enterprise IoT technology have quickly become one of the early adopters of blockchain technology. In an IoT network, the blockchain keep an immutable record. That is, that record which is not altered. Okay, it can handle the history of smart devices. Okay, this feature enables the autonomous functioning of smart devices without need for centralized authority. We can avoid centralized authority. As a result, it leads to a single point of failure. Okay, and the blockchain opens a door to a series of IoT scenarios that were remarkably difficult or even impossible to implement without it. For example, by leveraging the blockchain, IoT solution can enable secure, trustless messaging between the devices in a network. In this model, the blockchain will treat message exchanges between the devices similar to financial transactions in a Bitcoin network. To enable message exchanges, devices will leverage smart contracts. Okay, there is a program code which is used to make a smart contract, which then model the agreement between the two parties. One of the most exciting capabilities of the blockchain is the ability to maintain duly decentralized trusted ledger of all the transactions occurred in network. Each peer maintains its own ledger. Okay, if any change is happening means that should be validated, okay, by the entire system. This capability is essential to enable the many compliances and regulatory requirements of industry IoT application without need to rely on the centralized model. Then I wish to discuss about challenges for blockchain IoT. And before that, I wish to tell some demonstration. Okay, mention demonstration. Here, I just wanted to explain demonstration using solid language. Actually, blockchain application can be implemented by using the solid language. Okay, you can use a solid language in online itself by clicking remix ID. Here, it makes it of Ethereum as a digital currency. Okay, by using remix ID, we can create a blockchain application. Okay, we can do implementation of that. Okay, here I have one hello world application. Solid language is the object-oriented language which is executing under the JavaScript environment. Okay, like object-oriented programming, we have a class. Here it is named as contract. Here we need to mention the version details, other languages by using pragma, solidity, and version details. Here to use. Okay. Here I have one global inside the class here it is named as contract. My class name is there is contract name is hello world, which has one data member called message. Here we need to if you wish to create a if you initialize the value for a data member means I need to create a constructor. I think which is similar to object into program language. Here I have created a constructor with a message to initialize the value for a data member. Then I have function, possesses some argument. Okay, you can make public or private by using the modifier public modifier. Here I just update the messages. Okay, so this is a simple hello world application. If you wish to compile the application, you just click here, click this say, this dimension. Here we have compiler, different kind of compiler. Select the default compiler. Okay. This is here. Here we can select the language. Here I have selected the alt language. There are other languages also available. Full language. I have selected search language. Just click hello world. You will get the response here. After compilation, just click here to deploy the application. Here I just deploy the hello world application. You can pass the message. Just mention application. Click deploy. After deploying, just view the data. See here we have blocks. Block is created. True transactions mined and executed successfully. Here we have a transaction hash value, which is a unique fingerprint. Here, this is a unique fingerprint which is generated. Already told about the hash. It measures a STAR2 physics algorithm. And the contact address also mentioned here. The source, destination, everything is mentioned here. Here. So, sum to hash means there is a Ethereum limit, maximum limit. Here by default it is mentioned as 30 lakhs, I think so. 30 lakhs. So we can select a different kind of value. Okay. Weight, 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 winning, ether. These are the cryptocurrencies. Okay. So I have selected weight. Okay. We can make transactions, business transactions. Okay. We can implement the applications by using already. Here I have input, some input you have given no, that is encrypted. Okay. So by using hash value. Here, this value is encrypted. This is method. So with this encryptor one, so it will be displayed to the user. After decoding, your input is here, displayed here. This is the data that I have supplied here. The decode about output is available here. So everything mentioned here. Okay. This is the example for hello world application, which is developed by using Solid language. See here, I have functionalities which is defined in the hello world application. Update. Here I just mention limit to my name. Update. Okay. It just display the transaction details. When I click message, whatever information that is given is printed here. Okay. So the transaction smart contract is everything is implemented with the help of Solid language. This is one example, and I wish to show another example. See here. Here I have another contract, and I maintain the data maker counter. Then I have owner details. Okay. Then I have three methods. Okay. This skill method is used to test the contract owner details. Here I have three methods: addition, subtraction, then get counter details. Add function is used to add the counter value, which is by default it is mentioned as 5. And I have subtract function used to subtract the counter, and I have get counter to display the counter value. So just select this one, compile it. I just use compilation. Here I have compiled the application. Then go to deployment section. Deployment section we have environment. Just select the JavaScript environment because all the language you can be executed in different environment. I just selected the JavaScript environment. Here I just deployed it. When you deploy it, same thing, same blocks will be created, see here, everything mentioned here. Status, transaction has contact address from to, and transaction cost, how much cost happened because we have to change the data, and execution cost as value. Input is encoded here, and decode output is not visible. So these in details, block data are visible. If I wish to test the application, means you can do this here. Last section, I have initially the counter value is 5 only, no. Now I just add 2 times. Okay, now counter is 7, no. Just get counter, which is mentioned as 7 here. Okay, make a transaction. If I wish to subtract the data, I just subtract 3 times, I will get 4. Okay, simple application maybe done. So in a we can make transaction in distributed environment. So this is mean for local testing purpose. We wish to make transaction means we can call data. Okay, we can mention the address details and we can make transaction in address. Okay, you have to use correct address. Okay, recipient address to make transaction and that is possible. Okay, I just locally tested the application. Okay, just to make transaction in anonymously, we can use this. So this is a simple blockchain demonstration which makes use of solidity language. I hope you understood about solidity language. Please reply, participants. Yes. Okay. I just wanted to explain about challenges for blockchain in IoT. So there are many challenges for blockchain IoT, which is mentioned here. One is selectivity issues, storage issues, processing power runtime, naming discovery issue, lack of skills, and the legal and compliance issue. I explain one by one. Let's start with scalability issues. The scalability issues which is relating to the blockchain that leads to a centralization, okay, which is casting a shadow over the future of cryptocurrency. Okay, because IoT network are basically centralized. So if you wish to apply blockchain technology, means we need to decentralize the system. A typical blockchain implementation, all blocks are broadcast to and verified by all nodes. This leads to significant scalability issues because in this network we need to maintain distributed ledgers in every page. Okay, so we need to devise a system which scales well. So there is a big issue in blockchains and IoT. Then processing power and time. Processing power and time required to perform encryption for all the objects involved in a blockchain system is challenging one. IoT system is very diverse because we deal with different kind of systems, maybe hardware or software. In contrast to generic computing networks, IoT networks are comprises uh, several devices that have very different computing capabilities, and not all of them will be capable of running the same encryption from the desired bit because each system has own configurations. Okay, we does not have same kind of speed and processing power. Okay, that is a big issue in big blockchain with IoT. Next, storage. Blockchain eliminates the need for central server to store transaction devices, but the ledger has to be stored in the node themselves. Okay, so each node has its own processing power. There is a big challenge, and the ledger will increase the size as time passes. That is beyond the capabilities of a wide range of smart devices such as sensors, which have very low storage capacity. If you introduce more transaction ledger means we are in need of more storage capacity. But the nodes in the IoT system has low storage capacity and lack of skills. Because few people only understand the blockchain technology because it is an emerging technology, and they know about uh, how really works. When you add IoT to the mix, the number will shrink drastically. Okay, so there is a problem with blockchain and IoT. So it is a since it is a new territory in all aspects without any legal or compliance code to follow. It's a serious problem for the manufacturer and service provider. Uh, this challenge alone will scare off many businesses from using the blockchain technology. So we need to regulate the policies, laws, compliances, etc. So naming and discovery is another issue. The blockchain technology has not been designed for the IoT, meaning that nodes are not meant to find each other in the network. An example is the Bitcoin application in which IP address of the some centers are embedded within the block Bitcoin client itself and used by the nodes to build network topology. But this is not a case for IoT. But this exists Bitcoin approach will not work here for the IoT. IoT devices will keep moving all the time and it will change the topology continuously because since it's an RS network. Okay, so topology changes may happen. So the naming that is locating the devices and providing the naming system is very difficult. And now I'm in a position to tell the benefits of integrating blockchain and IoT. There are several advantages. Okay, I'll list one by one. First one is publicity. All participants in blockchain, all participants have the ability to see all the transactions and the all blocks that each participant have own distributed ledger. The contents of the transactions are protected by the participant private key, so even all the participants can see them. They are protected. Okay, that what are the data which is available inside the node, okay, are protected. If you have private key means you can easily get the data. The IoT system is a dynamic system in which all the connected devices can share information together and at the same time protecting user privacy. Next advantage is decentralization. The majority of the participants must verify the transaction in order to approve it and add it to the distributed ledger. There is no single authority that can approve the transaction or set specific rule to have a transaction setup. By using a consensus mechanism, we can validate the transaction if anyone changes the data in the node. So if we introduce decentralization, there is a massive amount of trust included in this since the majority of the participants in the network have to reach the agreement to validate the transaction. Therefore, the blockchain will provide a secure platform for IoT devices. In addition, it eliminates the centralized traffic flows and the single point of failure. That is, a failure of one system will not affect the entire system. Next benefit is resiliency. Since each node has own copy ledger that contains all transactions that have ever made in the network, so the blockchain is better able to withstand attack, okay, tampering attack, and other it is denial of sleep or denial of service attack. Even if one node was compromised, the blockchain will be maintained by every other node. Having a copy of data at each node in the IoT will improve the information sharing needs. However, it introduces a new processing and storage issues. Next advanced benefit is security. So it has enhanced security. Blockchain has enhanced security. It has ability to provide a secure network over untrusted parties, which is needed in IoT with numerous heterogeneous devices. In other words, an all IoT network nodes must be malicious to perform an attack. Okay. The next advantage is speed. The blockchain transaction is distributed across the network in minutes and will be processed at any time throughout the day. It has high speed when compared to the existing technologies. Next benefit is cost saving. Existing IoT solutions are expensive because of high infrastructure and maintenance costs associated with the centralized architecture. Okay. The total number of communications that have to be handled when there are tens of billion will increase those costs substantially. Okay. So the cost that you face is there is a high cost, which is because of the communication only. Next one is immutability. Okay. So immutability means that changes may not changes cannot be happened. If any changes happen, means we need to spend more amount of money to validate the transaction in the blockchain network. So the transaction cannot be altered in the blockchain if you use blockchain technology. Having an immutable ledger for IoT data will increase security, privacy, which are the major challenges in technology and all new technology. Next one is anonymity. To process the transaction, both buyer and the seller use anonymous and unique address number which keep their identity private. This feature has been criticized as it increases the use of cryptography in illegal anonymity. Of course, it may happen. However, it could be seen as a advantage if you use it for other purposes. If you use for productive purposes, means browsing is the best technology. But sometimes it may not happen. Some persons may use browsing technology for unwanted purposes. It may be used for good cases like electoral voting system. So these are the benefits of using blockchain with IoT. Okay. So with this, I stop this session. If you have any issues, means uh, just tell me. I will answer for the question. This is my contact detail. Just to make a note. I can support if you do research in blockchain, machine learning, and other technologies.
Thank you, sir.
Thank you, ma'am.
Participants, if you have any doubts, you can post it in chat box.
Participants, if you are having any doubt, kindly post it in the chat box or you can unmute and ask.
Thanks a lot for providing the opportunity to present the lecture, ma'am.
Thank you, sir. Puvili ma'am, kindly conclude.
Okay, ma'am. Thank you for this informative session, sir. Your
Thank you, ma'am.
most exciting talk on blockchain architecture, comparison between Bitcoin and the current banking system, key business benefits, advantages of blockchain technology, etc., will be useful for every participant. It was really an exciting session. We are sure all participants would have attained a good knowledge on the benefits of the integration of blockchain with IoT. Once again, we thank you for the valuable ideas, which will certainly improve our knowledge on blockchain. We are eagerly looking forward for such interactions in the years to come. Thank you, sir.
Thank you, ma'am.
Thank you, participants, for your patient listening and cooperation for all the 6 days. Thank you.
Uh, Thank
Dear
you,
ma'am,
participants.
will you please share the feedback form again?
Sir, by 3:20, the valedictory function starts, sir. So during the valedictory function, we will provide the feedback as well as the assessment links.
Okay, okay. Thank you, ma'am. Thank you.
Kindly participants have a break for 10 minutes and please be joined by 3:20 sharp. We will have the valedictory function at 3:20 sharp. So during that time, we will share the feedback link for this session and also the test link. Thank you all. Kindly take a break for 10 minutes. Thank you. Thank you, sir. Kanimutu, sir.
Thank you, ma'am. Thank you, ma'am.
Thank you, sir.
I shall leave, ma'am. Thank you.
நான் வந்துட்டேன். சரி சரி. நான் என்ன பேசணும் மேடம்? என்ன பேசணும்? இன்னைக்கு யாரும் சீஃப் கெஸ்ட்ல இருக்காங்களா இல்ல அவங்களா இல்லையா? ஓ சரி சரி. நான் ஒன்றும் பேசணுங்கிறதுல நான் ஏதோ பேசணும். ரெண்டு ரெண்டு ஃபீல்டு தனித்தனி இல்லை. சரி சரி. ரைட் ரைட். ஆன்ல தானே இருக்கு. தெரியுமா? ஓ லைன்ல இருக்காங்களா?
Hello. Sir, good evening, sir.
Good evening. Good evening, madam.
Okay, sir. Thank you, sir. We'll start, sir. Lively, ma'am.
Ma'am, good evening, ma'am. Sir, good evening, sir.
Good evening, sir.
Good evening.
Sir,
Good evening.
sir, by 3:20, the valedictory session will start. Another 4 minutes more, sir. Sir, shall we start, sir? Shall we start, sir?
You can start.
Okay, sir. Education is the passport to the future. Tomorrow belongs to those who prepare for it today. Happy evening to all present online. We welcome you all for the valedictory function of the Series 2 of AICTE sponsored STTP on IoT with blockchain applications and challenges. Hope we had a great time for these 6 days with lots of inputs on the concepts in IoT and blockchain. And now we are at the end of Series 2. May we now request Dr. Lata Jyoti, Professor and Coordinator of this STTP, to say a few words about the happenings of Series 2. Please, ma'am.
Thank you. Thank you, ma'am. This 6-day-long STTP was inaugurated on 4/1/2021 by Dr. Muruganandam Ponnuswamy, Professor and Registrar, St. Kitts Group of Institutions, Kerala, who also handled a session on IoT and its requirements, which was continued in the afternoon by Mr. P. Nilesh, IoT Consultant, Enterprise Building Training Solutions, Thane, on design and power blocks of IoT. We started the second day of our STTP with a discussion on building blocks, protocols and technologies, security and challenges of IoT by Dr. R.P. Ramkumar, Professor, Department of Computer Science and Engineering, Mallareddy Engineering College, Secunderabad, which was continued in the afternoon by Dr. T. Vairam, Assistant Professor, Department of Information Technology, PSG College of Technology, Coimbatore, on Introduction and Evolution of Blockchain. The third day STTP session was started with a discussion on components and concepts of IoT, identification and analysis of the different ways of integrating IoT with blockchain by Dr. D. Surendran, Professor, Department of Computer Science and Engineering, KPR Institute of Engineering Technology, Coimbatore, which was followed by Ms. C. M. Nagasudha, Teaching Fellow, Anna University, MIT Campus, Chromepage, Chennai, on techniques and cryptographic algorithms in blockchain for IoT and the research aspects in integrating blockchain with IoT. We began the we began the fourth day of our STTP with a discussion on applications of blockchain in industries and smart environments and about the future and security of blockchain-based IoT applications by Dr. B. Santosh Kumar, Senior Assistant Professor, Department of CSE, GMR Institute of Technology, Rajam, Andhra Pradesh. And in our afternoon session, we continued with a discussion on types of blockchains, public blockchain, Ethereum and its components by Mr. Komal Srinivas, Tech Specialist, UTC Hyderabad. The fifth day of our STTP was handled by Mr. T. Ramkumar, Project Manager, Aditi Software, Hyderabad, on the topic Solidity Language for Ethereum, Deploying Solidity Smart Contract in Ethereum Blockchain and dApps using blockchain. We began the last day of our STTP, that is today, with a discussion on theoretical and programming aspects of integrating blockchain with IoT by Dr. R. Devi Priya Ma'am, Associate Professor, Department of Information Technology, Kongu Engineering College, and it was continued in the afternoon by Dr. S. Kanimuthu, Associate Professor, Department of Information Technology, Katpagam College of Engineering, Coimbatore, on the challenges and potential benefits in the integration of blockchain with IoT. Now we are going to put our curtains down by this valedictory function, followed by an assessment on our STTP topic. Thank you.
Thank you, ma'am. Now we request the participants of this STTP to provide their valuable feedback. Participants, kindly unmute and provide your feedback. Anurag sir, please sir. Anurag sir, kindly provide your feedback, sir. Participants, anyone kindly provide your feedback.
No feedback?
Hello.
Yes,
Yes,
sir.
sir.
Good evening, ma'am. This
Good
is
evening.
Anurag Singh Yadav from SRM University. Uh, Hello, am I audible,
Yeah.
ma'am?
Yes, sir. You're
Okay, ma'am.
audible.
First of all, I would like to congratulate and thank you to the organizing committee of this wonderful session organized by your team. And we learned a lot about the blockchain and IoT for the industrial practice. Uh, Really thankful to the Veldor College of Engineering for providing such a great platform and we can say a knowledge sharing program for us. Thank you so much, ma'am. Thank you, everyone.
Thank you, sir. Thank you, sir.
Any others? Any other participant? Ma'am, that's all it seems. Ma'am. Shall we
Okay.
proceed, ma'am?
Yes, ma'am.
Thank you, participants. A man of commitment who always leads us towards success is our Dean, Professor Jayachandra, sir. May we now request him to give us valedictory address, please, sir.
Yeah, so thank you, everybody. Respected HOD, Dr. Jabin Begum, coordinators of this STTP, participants of our own faculty members and participants from other places. Good evening to everyone.
Good evening, sir.
Yeah, I think I have to give the feedback because participants are not coming forward to give their feedback. So feedbacks are essential for us to improve ourselves or to do better in our future STTPs. Whether it is good or bad, it is better to give your feedback. What you learned out of this can be conveyed to us so that we can change our program style so that it will suit your expectations. So that's what we are expecting, and somehow it is a general nature of all of us to hesitant to talk so or give a feedback. So that will be I think in future I think we can expect more feedback. Anyway, I'll thank Mr. Anurag Singh Yadav for his valuable feedback or for him to his willingness to give feedback, coming forward to give his feedback. Thank you, Mr. Anurag Singh. Blockchain, as far as I understand, it is a distributed ledger technology, right? Ledger technology. It is about to change all the aspects of digital business. So that's what I understand from the literature I have studied. To achieve this, how effectively devices will communicate with each other is IoT, Internet of Things. IoT connects people, places, and products. So with this IoT with suitable sensors and other hardware, blockchain can be fully effectively utilized. This is what I understand. That I think that should be the concept of this STTP. So being the last day, I don't want again continue with this subject. I thank our chief guest, Dr. Muruganandam, and all other valuable research persons for their valuable informative input. I congratulate the HOD of CSC and the coordinators of this STTP for organizing a nice STTP, and I thank all the participants for their participation by honoring our invitation. So once again, I thank you everyone. Thank you all. Wish you all the best. Thank you.
Thank you, sir. Thank you, sir. Thank you.
Thank you, sir. Nothing is important than Thanksgiving. An energetic lady who was instrumental in keeping us on track This is our head of the department, Dr. S. Jabin Beham. May we now request her to propose the vote of thanks. Please, ma'am.
Thank you. Good evening to one and all present over here through online. It is a privilege and a great pleasure for me to extend my vote of thanks on behalf of the Department of Computer Science and Engineering and the entire fraternity of Vailala College of Engineering and Technology to all those who have contributed in the way to make this validity function a grand success. First, we sincerely thank the AICT for granting the sponsorship to conduct this 6 days STTP on Internet of Things with blockchain applications and challenges. We express our heartfelt gratitude to our secretary and correspondent through H.T. Chandrasekhar sir, who gave us optimistic inspiration in all our activities. Thank you, sir. We are highly indebted to our beloved principal, Dr. M. Jayaraman sir, an intellectual scholar who gave us optimistic inspiration in all our activities. So thank you, sir. We thank our Dean, Professor P. Jayachandra sir, our COE, Dr. K. R. Valluvan sir, and our Administrative Manager, Mr. N. Peresami sir, for their eminent leadership and constant support in all our activities. Thank you very much, sir. We accord our sincere thanks to all the resource persons who shared their knowledge with us for the past 5 days and today. We also thank the HODs and faculty members, non-teaching staff members of all the departments and all the participants of this STTP who have actively participated on these 6 days. The knowledge gained from this 6 days STTP will help the academicians and research scholars. This hope, looking for your great cooperation for our STTP Series 3 from 1st February to 6th February. It has become appallingly obvious that our technology has exceeded our humanity by Albert Einstein. Once again, I thank the AICT for sponsoring this 6 days STTP and I thank everyone. Thank you very much.
Thank you, ma'am. Thank you all. Thank you, participants. We will have the series 3 of this STTP. It commences from February 1st. Kindly inform your colleagues and other academicians to register. Thank you all. Thank you all.